In this module, we're going to start off by building a basic rigid body setup from scratch, so we have an understanding of what the workflow will be like for when things get more complicated later in the course. To start with, let's open a new HIP file in Houdini 16 and drop down a geometry node. Alright, so let's drop down that geometry node. Let's rename that simulation. Let's check on real-time playback so that when we play back our simulation, we'll get the results we expect. And we can delete this file node. To start with, we're going to need some geometry for our simulation to process. So let's drop down Houdini's built-in pighead test geometry. All right, let's go ahead and translate up our pighead a little bit, and we can scale it down a little bit. And we don't need the texture and attributes that are on there, so let's drop down a clean node, which will remove our attributes for us. All right, let's view the clean node and check on remove attributes. And the asterisk means that it's going to remove all attributes on there. So now as you see, our texture is gone. Now we're going to need a DOP network. Now, a DOP network in Houdini is where you do the vast majority of your simulated effects. And we can attach our geometry to the first context input right there, view the DOP network, and jump inside. Now, one thing that all simulations need is a solver to process our data. And Houdini has a couple of great rigid body dynamic solvers. To start with, we have the Houdini RBD solver. For a long time, it was the native default solver in Houdini, but it's a little bit slower than the other options. And so next we have Bullet, which is now considered the default solver in Houdini. It's the solver you're going to use 99% of the time. It's extraordinarily fast, it's very efficient, and it can handle a lot of geometry, which what makes it great for destruction. Now there is a third type of RBD solver, of rigid body solver in Houdini, and it's called the ODE solver, or Open Dynamics Engine. It's also super fast, however it limits you to only being able to use geometric primitives like spheres and cubes to be able to do your simulations, which as you can imagine, it's not very accurate for complex geometry. And I'll explain a little bit more about what that means later in the course. All right, so let's click here in the network view and then hit Control B, just so we have a little bit more screen real estate here. So we were just talking, we said there is the RBD solver, the Bullet solver, the ODE solver, and there's actually one more that's good to know, and it's called the rigid body solver. And so what that actually is all of these other solvers bundled into a tool so that you could use all of them. So if we look at it here, there's a drop down where you could use RBD, ODE, or Bullet, and there's controls for each of those. And if you were to jump inside of this, you would see that it's a bunch of solvers connected with some switches in there that gives you control. There are instances where you might want to use this, but a lot of the times you're going to want to build up your dynamic simulation yourself. But it's good to know that's there in case it comes up. And so we're not going to use the ODE solver, and we're not going to use the RBD solver. I just wanted you to know what they look like and where they are. So we connect that to our output. Now we need to bring in our pig's head so that we can simulate it. And to do that, we have to create an object to store that data. And there are two types of objects that would work with the Bullet solver. There's a regular RBD object, which you can see here. It's got a little rubber ducky on it, and that would work fine. However, later in the course, we're going to be working with a lot of geometry, and there's a great workflow in Houdini with what's called packed primitives, which I'll have a clip on a little later. And just to keep the workflow the same, whether we're working with one object or many objects, we're actually going to use a packed object. So an RBD packed object, and now you'll see that has a bowling ball and some bowling pins on it, and we're going to use that. However, let's hit Control B again so we could see our viewer. If we were to just here, say first context geometry, this, and connect it, and let's put down a gravity so there's some forces working in our objects. So now let's just hit play and see what happens. Our geometry is not moving, and there's a reason for that. Our RBD solver is expecting packed object from this node. And this node's not able to read our pig's head properly because our pig's head has not been packed yet. So let's jump back up a level. And in between our clean node and our DOP network, let's put down a packed node. Let's go back to the first frame and jump into our DOP network. Now hit play again, and now it's falling. That's important to know. All right, but we don't want our pig's head to just fall through the ground. That's a very boring simulation. So let's put down a collision. Let's put down a ground plane DOP. If you look at that, what it's doing is creating an infinite plane. So even though it looks like it only takes up this much space, these arrows tell you that it goes on infinitely. So even if we had objects falling off to the side here, they would collide with the ground plane. All right, let's view our output again. So the workflow in Houdini used to require you to put down a static solver to understand the information that you're putting in for your collision. That's no longer the case. So what we're going to do is put down a merge node. Now, if you look at this merge right here, it actually has what type of relationship you want the two merged DOP objects to have. And it's set to collide relationship automatically. So let's connect our ground plane. Let's connect our gravity. And then let's connect that to our output. And then if you look, it says left input affects right input. We want our ground plane to affect our pig's head. And a collide relationship, like I said, so that we're already good to go. So if we zoom back in on our pig's head to see what it's doing and hit play, we have interaction, which is exactly what we're looking for. So just now we created the simplest rigid body solver we can from scratch without using any shelf tools. So hopefully you have an understanding of how everything's connected. And in the coming courses, we're going to make this more and more complex.